Each element specifies the input port number. Initial permutation and final permutation are reverse of each other. The initial and the final permutations are straight P boxes. Middle part of the structure of DES, we have the fiscal round. Hello students, welcome to the next session of Network Security. I am Dr. Soumyashri from Department of Computer Science, Vidhyaashram College. In the last session, I was discussing about one of the symmetric block cipher, that is the data encryption standard, which was the standard cipher method approved by the International Standard Agency, okay, NIST. Okay, this data encryption standard will keep the cipher in block, and these blocks are encrypted and decrypted. In the last session, I explained something about the structure of the DES. What are the normal methods of DES or normal structure of DES is, it contains two permutations, that is initial permutation and the final permutation, along with that 16 fiscal rounds, isn't it? After 16 fiscal rounds, you will get the final permutation, is it not? The initial permutation and the final permutation are keyless combinations. That means they don't use any key, but they will permutate the input and the output, isn't it? Where initial permutation and final permutation are reverse of each other. Even though you skip the permutations in cipher method, that is initial permutation and the final permutations are skipped, there is no much difference in the cryptographic procedure. But we don't know why they have introduced this permutation. Maybe to increase the complexity to the cipher method, so that adversary can take that little bit difficult to decrypt that. Alright. So this initial permutation and final permutations are called as P boxes, that is permutation boxes. So these boxes are used in the first step as well as the last step, isn't it? In the last session, I explained about these things, isn't it? How does the data encryption standard will follow, along with how they are going to permutate in the initial step and in the final step. Let us move on to the next thing in DES, that is the tables. We have to generate the initial and the final permutation tables. Permutations will generate tables which gives you the values to the table. Okay, this table is like a matrix. Okay, as we said, there is a 64-bit input with a 56-bit key set or key value. Okay, these will be combined to form an encrypted text or the cipher text, isn't it? Now, in the last session, I stopped the discussion till the permutation. How does the permutation happens in the structure of DES? Today, in this session, let's take how does this initial and final permutation will permutate the input and the output values. Alright. Now, we have the permutation rules for these P boxes. P boxes is nothing but initial permutation box and the final permutation box. That means there will be a hardware part and a software part for permutating. For permutating in the initial position, we will be having a box which is called as the P box. In that box, we will have a software for permutation. Again, in the final step, final permutation, we will be having another permutation box or P box, which contains the software to final permutation. Okay, the permutation rules for the P boxes or permutation boxes are as shown in the table. So this is initial permutation table and the final permutation table. Okay, each side of the table can be thought of as a 64-bit element array. We have 64 bits, isn't it? 8 columns and 8 rows. Total 64 elements are there. As I said, there is 64 input to the P box and 64 output. So, the table has an array of 64 bits with 8 cross 8 matrix, or represented as 8 cross 8 matrix, or 8 rows and 8 columns. Same with initial permutation and final permutation. How much is there in the initial permutation? That much bits must be there in the final permutation, isn't it? So, other thing what you need to know about these permutation tables is, it is a 64-bit element array. Apart from that, the value of each element. So, we have these values like 58, 50, 42, 36, 30, 24, 35, 29, 23. Like this, we have elements in the array. Okay. The elements defined in the input port number. Each element specifies the input port number, from which input port number the value is coming. So this is 58 input port. If you have 64 bits of input port, in that this is the 58th input port. Okay, number, and the order of the element. Order, which is the order of element, is 0th row and 0th column. So this position or order of the element represents the output port number. That means the input from 58th port will be permuted to first port. Okay, the element from the 50th port is permuted to second port. Okay, the position represents the output port, whereas the value represents the input port. All right, here same thing, 34, 26 represents the input from the 26th port that will be permuted to the 5th position. All right, 0, 1, 2, 3, 4 or 4th position. If you take from 0, it is 4th position. Now, 18 is, input is from 18th port. Value of each element defines the input port number. 18th is the input port number, whereas the output port number is the 6th port. Okay, like this, the number or the element shows the input port number, whereas the position of the number specifies the output. Okay, in the final permutation also same thing happens. Suppose if it is 40, means the input port will be 40 and is permuted to the first position. All right, the number 47, if you take the number 47, 47 indicates that the input port is 47, whereas output port is 10. Okay, this is 8, 9, 10, 11. Okay, output port is 11. Okay, if you take this, the input port is 25, whereas output port is 64. In the same way, the input port is the 7 and the output port is 64. Okay, this element array will give you the hint of the permutation in initial P box and the final P box. Okay, the initial and the final permutations are straight P boxes. Okay, in these permutation boxes, we have three types of P boxes. One is the straight P box. Straight P box. Another is compressed P box. Third one is the expansion P box. Straight P box, compressed P box and the expansion P box or permutation box. What is the difference between straight box, compressed box and the expansion box is straight P box will have n cross or n order of input port and the output port. That means equal number of input ports and output ports will be present in straight P box. That means permutation can be done for the straight ports, which is called as the straight P box, where if you have 7 input ports, you can have 7 output ports. This is used when you have same number of inputs and same number of outputs. So in such a case, you can make use of the straight permutation box. Okay. Whereas in compression P box, you will be having n number of input ports and m number of output ports. Number of output ports will be less than the number of input ports as shown in the diagram. In this example, we have 7 input ports where the number of output ports is only 5. What happens to other 2 ports is those 2 ports will be blocked. Okay, those 2 ports will be blocked and their value will be suppressed so that the output will have only limited or less number of outputs. Okay, in this example, we have given 7 input ports, that in 7 bits have been inputted, whereas the output contains only 5 bits. Okay, since it compresses the size of the box, if you consider the permutation box as a square box, you are going to compress it to have less number of output ports. It is called as the compression P box. Alright, here we have the compression P box. We use this compression P box when there is a necessity of reducing the number of output ports. Whenever there is a necessity of reducing the number of output ports, we can make use of the compression P box. Contrary to compression P box, the expansion P box will have n number of input ports and m number of output ports, where n comma m, where output ports will be greater than the number of input ports. M will be greater than n. In compression P box, m will be less than n, that is output port will be less than input port. But in expansion P box, number of output ports will be more when compared to the input ports. Like in this example, we have 3 input ports and 5 output ports. You may have any number of output ports, but must be more than the input ports. What happens that only 3 can be ported, but in expansion P box, 1 input port is permuted to more than 1 output port. In this example, you can observe the input port 1 is permuted to the output port 1 and 4, whereas the input port 3 is permuted to output ports 2 and 3. Okay, we have this expansion P box where it will be expanded. Whereas compression is reduced, expansion is increasing the size of the output ports. Okay, well, that is why it is called as the expansion, expanding the number of output ports. When do we use the expansion P box is when we need more output for the given input. In such a case, we can make use of the expansion P box. Okay, this is about the permutation boxes, that is straight P box, compression P box and the expansion P box. In this, the initial and the final permutations will be straight P boxes that are inverse of each other. As I already said, the initial and the final permutation boxes or P boxes are inverse of each other. In cryptography, there is no significance for this permutation boxes or P boxes. But even then, the data encryption standard or DES follows the method of permutating the ports or permutating the input and the output or input values using the P boxes. Exactly don't know the reason of use, but maybe to make it little more complex, because even they don't use any key. They are keyless permutation boxes. All the three boxes like straight, expansion and compression, all the permutation boxes are keyless boxes and doesn't have any significance in the DES. Still they are in use. When it comes to the middle part of the structure of DES, we have the fiscal rounds, isn't it? The fiscal rounds are 16 in number. Again, the fiscal rounds are not as simple as shown in the diagram. It again contains several steps to perform this round using the key. This fiscal rounds are key rounds where they use the 56-bit cipher key to generate a output. Alright, each round of DES is a fiscal cipher. The actual ciphering happens in these fiscal rounds. Let's take how does this fiscal rounds will permutate or execute or cipher the plain text. Alright, here we have the structure of the fiscal round. This is the structure of one single fiscal round. Alright, here we have the fiscal round where the 64 bits of input, that is one message, entire message is divided into blocks. As I said, it is a block cipher. Each block contains 64 bits. The 64 bits is again divided into two parts of 32 bits each, because what is the size of our key is only 56 bits. But the block size is 64 bits. You cannot accommodate extra bits, or you cannot combine the 56 bits with all the 64 bits. To make this possible, the 64-bit input is divided into two parts of 32 bits, whereas first part of 32-bit is recognized as L and next part of 32-bit is recognized as R. You can simply take it as left and right. Left 32-bit and the right 32-bit. Like you can observe here, they have given the name or they have given the index value I-1. Why it is I-1 is this 32-bit has came from the initial permutation, isn't it? From the P box. So this is considered as I-1. If from 0th count they are taking, so it is I-1. If the iteration is not happening. Since this is considered as assumed as the first round, we take it as I minus 1, which gives the output of I, that is incremented. Okay, when you look at the algorithm, you'll get to know the increment value. You know about the incrementation process, isn't it, in the programming language? The same thing happens. The initial procedure or initial 32 bits will be taken as L I minus 1 because it is the first step. Okay, here this is R I minus 1, right? I minus 1. Okay, these are applied or these are obtained for mixer. Mixer is going to mix these bits. How it is going to mix? We have mixer and swapper in the round, fiscal round. What does the mixer will do is, it will perform the XOR operation. You remember the XOR table and XOR operation, isn't it? So it performs the XOR operation on the left part. Left part is taken as it is. Left 32 bits are taken as it is. Now, right 32 bit will be here. It is combined with key. What is the size of the key? Key is of 56 bits, isn't it? Key size is 56 bits. Okay, this 56 bits key is combined with 32 bits, okay, which will give you the right function of R of I minus 1, comma, Ki. First key is used, okay, permutation of, okay, 32, permutation of 32 bits, okay, from 56 bits, first permutation of 32 bits is taken for XOR operation. These two will be combined for XOR operation, Li minus 1, Ri minus 1 combined with Ki. So you can perform the cipher in additive or multiplicative cipher. Any function you can use. It will give you the first cipher in this mixer. It mixes the 32 bits from L part and 32 bits from R part, applying the key. Okay, this result from XOR operation is supplied to the swapper. What is the task of the swapper is to swap the inputs, what it has got. It will swap the L part of the 32 bits to the R part, whereas the R part of 32 bits will be swapped to L, which becomes Li and Ri. Alright. So each L and R bit again contains 32 bit, in total 64 bits. Okay. There are 3 steps. One is taking the L and R part, combining R part with the key. Again, key is combined with L part. Okay. Both the L and the R part is combined, or it is performed XOR operation with the key, and this output will be taken by the swapper, which swaps the L part and the R part. Alright. So the round takes the L of I minus 1 and R of I minus 1 from previous round, or if you take it as the initial round, will be 0. And they are taken as Li and Ri, which goes to the next round. And again in the next round starts with L of I minus 1 and R of I minus 1 and generates Li and Ri. Okay. We can assume that each round has 2 cipher elements, mixer and swapper. First is the mixer and next is the swapper. Okay. Each of these elements is invertible. That means you can first swap and then can mix, or you can mix and then can swap. It doesn't make much difference. we have to follow both the methods in any order, mixer and swapper. Okay. All non-invertible elements which are not invertible are collected inside the function f of r I minus 1 comma k1. That is, the key one will be taken. The elements that are non-invertible, okay, which cannot be inverted, will be collected inside the function, all right, which will be XORed with the other part. Okay, here we have the function of the DES. Okay, the heart of the DES is the DES function. How does it functions or how does it operates? All right, the DES function applies a 48-bit key. Okay, this function applies 48-bit key, not the 56, entire 56. Only 48-bit key is applied, okay, to the rightmost 32 bits to produce a 32-bit output. All right, here we use 48-bit key with 32 bits to get a 32-bit output. 48-bit is the number of input and 32 is the number of output. So what is the permutation box you have to use is the expansion permutation box, isn't it? From the input 32 bits, we have input of 32-bit ports combined with 48 bits of key to form 48 bits. So it will be expansion box, okay, that we use. Here is a diagrammatic representation of the DES function. First thing is they apply f of r minus I minus 1 comma ki. So this is this procedure, the mixer, how does it is going to mix. Okay, in will be 32 bits from right or left. Any one part you can take which is non-invertible. Okay, the 32 bits will be applied to the expansion P box. It will be expanded to total of 48 bits. Okay, this 48 bits is combined with 48 bits of key, which is ki in that particular round, ki, which will be XORed, expansion R or XOR will be applied here. Okay, so XOR operation produces 48 output bits. These 48 bits are applied to 8 S boxes. What is S boxes? Substitution box. S box refers to substitution boxes. Which again follows one of the substitution cipher. Okay, DES uses both the block cipher as well as the stream cipher and one of the substitution cipher. Any of the substitution cipher you can use. These substitution ciphers or substitution boxes contains the hardware for substitution as well as the software for substitution. We have the substitution boxes. The substitution boxes produces 32 bits. Okay, 48 bits is again converted to 32 bits using the compression P box. Okay, S box will have compression P box. We'll study it in the next thing. Okay, again these 32 bits are applied to the straight P box which produces the output of 32 bits. Alright, this is how a DES functions. Okay, in the round. But it is in the mixer. Swapper is nothing much special. It just swaps. The main thing happens in the mixer. How does they are going to generate those 32 bits with ciphering, not the normal cipher text of 32 bits will be produced using this structure of DES. Okay, here we have expansion of P box. Okay, this is the procedure of the DES or function of DES. In the next session, I'm going to explain you all the three boxes, that is expansion, substitution box as well as the straight P box. How does they are going to generate the cipher text. All right. Thank you.